Hello, everyone, and welcome to our Chapter 8 lecture for our CIS 2757 course, C# Programming. In this lecture, we're just going to go over some of the concepts that are inside of Chapter 8. So we will be looking at how to store and manage multiple values efficiently, the differences between arrays and collections. I'm going to change this to say differences instead of difference. And when to use one-dimensional, which would be like our regular arrays, rectangular, which is 2D or multi-dimensional arrays, and jagged arrays, which are a form of multi-dimensional array. And then how to work with common collection classes such as lists, stacks, and queues. So why do we need arrays, or collections for that matter as well? Well, variables can only store one value, and many of the programs that we are going to write require storing multiple related values, okay? So test scores, right? This could be an int or a float, depending on what you're storing. Names, you could need multiple strings, and prices, which would be multiple decimals, right? So arrays and collections allow us to store data efficiently, loop through that data easily, and write cleaner and more scalable code. So let's just start off with one-dimensional arrays, which are our normal arrays. Normally, if you hear people just say arrays, they're referring to one-dimensional arrays. These store a fixed number of elements, right? And all of the elements in an array, they need to be the same data type, right? So you can't mix and match. You can't have strings and ints and decimals all within the same array. It needs to be an array of one data type. And each element is accessed by an index. And do note that indexing starts at 0, not 1, right? So I have an example down here. So our array at index 0 is storing the value 10 here. And then our array at index 1 is storing the value 20. Our array at index 2 is storing the value 30, and our array at index 3 is storing the value 40, okay? So hopefully this explains the difference between the index and the value. So arrays all have indexes, okay? And these indexes start at 0, and they work up to whatever length the array is, and then it can store different values at each of these indexes, okay? So how do we create an array? And I do actually have a C# program open here. I've gone ahead and just added in a lot of this code just to save time on the lecture, but we're going to go through it and look at it. So the syntax for creating an array, I have it in here in the slides, but I also have an example over here. So obviously with variables, right, we can declare a variable and initialize a variable. Same thing with arrays. We can declare an array, right? So here we have a int array named example, right? And the way we declare an array is with these open and close square brackets here, okay? So next to the data type, you'll put the open and close square brackets, and this is saying an array of ints that is named example, okay? And then we need to initialize an array, right? And what we need to do is we need to allocate space for the array, okay, in memory. So example, and then we use the equals assignment operator, and we're going to use the keyword new, and it's going to be an int array of size 5 is what we're saying. So this is how big the array is, okay? So if we're thinking in terms of index, of the indexes, it would start at 0, right? So it goes 0, 1, 2, 3, 4, and you would actually end at index 4 because it starts at 0. Okay, so that's something that can trip beginners up a lot when working with arrays. So it is something very important to keep in mind, right? This is the length, but that doesn't mean that the array goes up to 5, as in there is no index 5. It would start at 0 and it would go up 5 times from there to have 5 different indices. And then right here, you can see that we can combine the declaration and initialization into a single line, right? So we have an int array called numbers that we are assigning the value of a new int array of size 5. And remember that this is actually creating or allocating the space in memory for this array. Okay. So in the slides over here, you see that the int and square brackets, it defines the array type. The new int of size 5 allocates space for 5 elements in the array. And elements are initialized to default values. So for an int array, they will be initialized to 0. Okay. So as of right now, as of this line of code right here, our array is actually of size 5, and it every index has the value 0 in it. Okay. And I could actually show that if I came right here and I did a console.writeLine, and we did this, and then, well, it would be, we need to print it out. So I'm just going to borrow this from down here. Because we would need to loop through each of the indices in the array. So we'll explain what this code means in a little bit here in just a minute. So don't worry too much about what it means. Just know that we're looping through every element in the array, and we are printing each element inside of the array. Okay. And I am going to add at the end here a console.writeLine, and it is just going to be an empty string because we just want to have a space in between our next thing. So when I hit run here, you're going to see a bunch of stuff in the console. That's because we have a bunch of stuff printing here. So don't worry too much about it yet. If we just scroll to the top here, I'll go ahead and highlight it. These rows right here. Oops. These rows right here minus the 1. There we go. So as you can see right here, we have our array of ints, and it's called numbers. And you can see there's 1, 2, 3, 4, 5 zeros. And that's because we are looping through every element in the array. Okay. And remember, the array is size 5. So there should be 5 zeros here. And they've all been initialized to the default value of 0 for the int array. Okay. So now we can look at what it looks like to create and initialize an array on one line. Okay. And I don't actually have a line for that over here. But this is something that you can do as well. So let's say that our int numbers array, instead of declaring a new int array of size 5 and allocating the memory for that, let's just say we knew the values already that we wanted to be in our array right then and there. Okay. So what we could do is we could say equals and then open curly braces. And inside of the curly braces, we would just put our values. Okay. And what this is doing is it's still allocating space, five spaces in memory, right? Because there are 5 elements in the array here. So it's still an array of size 5, but we're just actually assigning the values of the array to the indices right here in the declaration and initialization. Okay. And there are some advantages to initializing an array with values. Okay. You can have cleaner syntax. You don't have any need to specify the size explicitly, right? So right here in our code, you can see that we're explicitly saying the size of the array. Well, you don't need to do that here because the size is however many elements are in this array. And the size is determined automatically, right? Which we just talked about. We can also, of course, assign values to array elements, right? So I've gone ahead and done that in the code here. So as you can see, we can assign these values to an array. Do note that, again, arrays have a fixed size, which I say a little bit later here. So that means that we cannot make this array numbers. We cannot make it any bigger than, we cannot make the length any bigger than 5 during runtime. So they have a fixed size. So that is one of the limitations really of arrays, but it can be good in certain circumstances. So if we want to assign values to array elements, we simply say our array name, and then we want to specify the index that we are assigning a value to, right? So here we're assigning the value 100 to numbers at index 0, okay? On the next line at numbers at index 1, we're assigning the value 200. And then at numbers at index 2, we're assigning the value 300, okay? And again, important rules. The index needs to be valid, right? So we can't use a number outside of the range of the array right here inside of the square brackets, okay? So your index needs to be in range. If you try to access an invalid index, it will cause a runtime error, okay? And arrays have a fixed size, as we talked about before. So how do we actually work with arrays here? Well, one of the things we can do, obviously, is we can access them from console.writeLine, right? So here I have console.writeLine, and you can see that we are going to write to the console numbers at index 0, and this is going to display the value at index 0 in our array. We can also use a very useful property that we get with arrays called length, okay? And the way you use length is you just have the name of your array and then you say dot length. Remember a capital L because it's a property, no parentheses. Okay. And here we're saying console.writeLine numbers.length. And what this is going to do is it's going to display to the console the length of the array. Okay. And then right here, I'm just creating an empty space in between our console.writelines. Okay. So what does length do, right? It returns the total number of elements, and you'll often see length get used in loops, which we'll see in a second, but let's run this really quick. So if I scroll all the way up, you can see that our numbers at index 0 is printing 100, and you can see we're printing 5 for the length of numbers, okay? And obviously we can change this to make this a little bit cleaner if we wanted to. I'm not going to do this for all of them for the sake of time, but I'll show you. So here we could say index 0, so that way we know what we're printing there. And then right here, we might say, let's see, length, oops, if I can type, length of numbers array. And then we'll say that. And then if we go ahead and run this now, just to show you, you can see that we're saying index 0, the value is 100, and the length of the numbers array is 5, okay? So moving on here, we can also use loops with arrays, right? So this code is actually over here in the Visual Studio, so I'm going to look at it there. So as you can see, we can use for loops to actually use arrays with loops, okay? So in our for loop here, we are saying int I equals 0 like normal. And then what we're doing is we are saying I is less than numbers.length, okay? And so what is this doing? Well, what we're doing here is we're looping through the array, okay? So since I starts at 0, while I is less than numbers.length, so in our case, right, numbers.length is 5. While I is less than 5, then we are going to do whatever we need to do to the array at this index, okay? And then we are going to increment I, and then we'll do it to the next index, right? So in our case, all we're doing is we are showing it to the console, right? So in our first, we'll go through some iterations of the loop here together, right? So int I is equal to 0. 0 is less than 5. So what we're going to do is we're going to write to the console numbers at index 0, okay? Because remember, I is equal to 0 right now. Now that we've done that, I will plus plus, so that means it will be 1 now. So 1 is less than 5. Again, we'll write numbers at 1 to the console, and then it will keep doing that until I gets equal to 5, right? Now, 5 is not less than 5, so we are not going to try to write to the console numbers at index 5. And that's actually a good thing, because if you remember, because our indexing starts at 0 with arrays, numbers.5 or numbers at 5 doesn't exist, right? So another way you can get tripped up a lot as a beginner is if you write something like I is less than or equal to numbers.length, okay? So if I write this here, we're going to see that we're going to get an error here, okay? And that's because we're trying to access an index that is out of bounds, okay? So here you can see we started printing through our array, and then we got an exception thrown, okay? And you can see it's index out of range exception. So the index was outside the bounds of the array, okay? So that is because it sees that 5 is equal to 5, so it's going to try to do this line of code, but numbers at index 5 doesn't exist because our array only has 5 elements starting from 0. So that is something to be mindful of when working with arrays. So keep that in mind. Remember that it starts at 0. The index starts at 0, okay? But running this like normal without the exception, you will see that we are printing out our array right here. So you can see we print the first 3 elements. If you remember up here, we assigned the first 3 elements values, and then the other 2, we didn't assign them anything, so they are still the default value of 0. Awesome. Now we can move on to a variation of the for loop, and it is called the for each loop, okay? So what the for each loop can do is it can be used to iterate through arrays or other collections, okay? And the differences between a for loop and for each loop are read-only access for the for each loop, okay? So the for each loop cannot make any changes to the array or collection. It can only read it. It has a bit of cleaner syntax than using a for loop, and there is no index variable needed. Okay, so I have an example of the for each loop being used right underneath here. You can see in our for loop, we need to use this index variable I, and we need to do the I++ and everything. With a for each loop, it is much simpler. Okay, so if we're trying to loop through our numbers array, the simple thing to do is to say for each, and then we will say int because our array is an int array. And then we're going to declare a variable called num right here. And then we're going to use the keyword in, and then we'll specify our array or collection. So for each int num in numbers, we are going to do blank. And in our case, we're going to say console.writeLine num, and that is going to basically do the same thing that this for loop is doing right up here. So I'm actually going to add a print for each of these. So we'll say console.writeLine here. And we will say using a for loop here. Make sure we put a semicolon at the end, and then I'm going to copy this line and put it right down here. And then we are going to just change it to say using a for each loop. Okay. So let's go ahead and run this really quick. And if we scroll up, you can see that they have the same exact output, right? They're doing the same thing, but you can see how the for each loop is a lot cleaner looking than the for loop, and it's a little bit easier to write. So for each loops can come in very handy, especially when working with our different collections and arrays. Now let's move on to a little bit of a more complex version of arrays. And these are called rectangular arrays, or you could hear them called 2D arrays, or even multi-dimensional arrays. And it is exactly what it sounds like. So what is a rectangular or multi-dimensional array? Well, it represents data in rows and columns, okay? And do note that in a rectangular array, all rows have the same number of columns, okay? And this is commonly used for tables and grids, okay? So I've done my best to do a visualization in the comments here. So hopefully this will help you visualize a bit better what this looks like. But first, let's look at the syntax of creating a rectangular array. So what we do is it's the same, but we're going to use a comma inside of the square brackets. And this comma is signifying that this array is 2D or multidimensional. Okay, so we're creating an array named grid. It is a multi-dimensional array, and we are assigning it the values 3, 4. So that's 3 rows and 4 columns. So what does this grid or array look like behind the scenes, right? Well, it kind of looks something like this right here, right? So at 0, 0, so if we were to say grid at 0, 0, it would be this first index in the array. Okay. And again, we have 3 rows here, right, going down, and 4 columns. Okay. So we have our 1, 2, and 3 row here, and our, our first, second, third, and fourth column here. And an important thing to note, right? This still uses 0 indexing. So when you're looking at the rows, it goes 0, 1, 2, but it is still 3 rows, right? And you can see that visually here. And then same thing with the columns. It starts at 0 and it goes up to 3, but we still have 4 columns, okay, in our grid array. So here you can see that we're assigning some values, right? So we kind of do it, if you'll refer up to how we assign values in a regular array. This is practically the same, but you need to specify the row and column that you want to assign the value to, right? So the first number is rows, the second is columns. So our grid at 0, 0 is 10, at 1, 2, it's 25, and at 2, 3, it's 50, okay? So if we were to look at this same exact setup right here, but with the values that have been assigned, you can see how this would look, right? And all the unassigned ones will be 0 because that is what they are defaultly initialized to here, okay? So, and then remember, to access the values in an array, you must provide the row and column, right? We already talked about that. Just catching up on my slides here. So looping through a rectangular array, okay? So what we can do is we actually nest a for loop inside of another for loop, okay? So we can say for int row is equal to 0. So we're looping through our row first. And while our row is less than a grid.getLength at 0, okay, so we're getting the length of the first element here, and then row plus plus, and then we also have an inner for loop where we're going to go through each of the columns doing the same thing, and then we will write grid at row and column, and then a space in between. So if I go ahead and run this, you can see what this would look like. So it's this line right here. I've put them on the same line here. So as you can see, we have 10, and then we should have 3 zeros. So that's our first row. And then we get our second row where we have 0, 0, 25, 0. And then our third row should be 0, 0, 0, 50. Okay. So you can see that we're looping through the entirety of our multi-dimensional array here. Okay, and you don't have to use row and col. You could use I and j as well. Those are very common for nested for loops to use I and j, and I do use them in a minute here when we look at jagged arrays. So what is a jagged array? So a jagged array is best described, I think, as an array of arrays. Okay, so each inner array can have a different length, and it's a lot more flexible than a rectangular array. So, for example, row 0 could have 3 elements, row 1 could have 5 elements, and row 2 could have 2 elements, okay? So, here I go through creating a jagged array, and you can see that right here. So, you can see that to create a jagged array, we actually use 2 sets of square brackets instead of 1 set of square brackets or a set of square brackets and a comma. 2 sets of square brackets. And we initialize it. And the first thing we initialize is our row, how many rows we have, okay? And then separately, we can say jagged array. So our jagged array at our first row is equal to a new int of length 2, okay? So there will be 2 columns in the first row. In the second row, there will be 4 columns. And in the third row, there will be 3 columns, okay? And I've done my best to create a visualization for you right here. And you can see how this could be considered jagged, right? Because you can have different amounts of columns from row to row, right? And then the way we assign, very similar to the other ones, you just specify the row and the column, and then you assign the value. And we can loop through jagged arrays as well, right? So kind of the same idea with the nested for loops. Here I'm using I and j. And on the outer for loop, we check if I is less than the jagged array dot length. Okay. And then for our j in the inner for loop, we're checking if j is less than the jagged array at I dot length, right? And that's because the jagged array dot length, we're checking this first number right here. We want to make sure that we are less than 3. And then on the inner one, we are checking for the specific I or row. Are we less than the length of the row? So in the first row's case, it would be 2 elements, right? The second row would be 4. The third row would be 3. And then we're just printing out the jagged array here. And I can go ahead and run this to show you. So this one is printed a little bit wonky because I didn't use right. I just used right line. But if we follow this pattern up here, you can see at 1, 2 is where we assigned our value. So you can see we've got 0, 0, 0, 0. So there should be 4 zeros. There is. And then 50. Yep. And then we have 4 more zeros. So you can see how that prints out right there. So there's also the array class. The array class provides us with some methods. There's a couple common methods here that I've listed out that you will probably use when working with arrays. The first is sort. So sort sorts the elements into ascending order. And then there's also copy. And what copy does is it copies some or all values in one array to another array. Okay. And I've shown both of those get used here. So here we have the sort method. So we're calling numbers.sort. This sorts our numbers array. Hello class, it is me from the future tagging in for a second here. Sorry, when I was writing this, I wrote this very fast and I even had it correct inside of my slides, but I didn't have it correct in the Visual Studio file. I'm actually not positive. I'd have to look into it further. I'm not positive why this line of code didn't cause an issue because you're actually not supposed to be able to do this with arrays, right? So what you're supposed to do with the sort method is call array.sort. And then you would pass in the array you want sorted. In our case, it would be numbers. And that is how you would actually properly use the sort method from the array class. Again, I'd have to look into it. I'm not sure why it didn't cause issues, but array.sort is how you use sort, and array.copy is how you use copy. It's correct in the slides. I just was going through this part really fast when I was setting up the code for the lecture, and I missed it. And because it didn't have an error, it didn't jump out at me. But I just wanted to correct that just so you guys didn't run into an issue where you were trying to do it the other way and it caused any type of error for you guys. So just remember array.sort and array.copy need to be used for the sort and copy method. All right, I'll jump back to past me in the lecture now. And then here we're printing out the numbers array, the sorted numbers array. So if I go ahead and run this and I scroll up here, you can see that our numbers array has been sorted in ascending order, right? So we have 0, 0, 100, 200, 300. If you'll remember, this is our numbers array from before. We had 100, 200, 300, 0, 0. Okay, so this is the sorted variation. And I'm going to go ahead and leave this running really quick because we're looking at copying next. So here I have declared a new array called copy. And we are setting it equal to a new int array at numbers.length, right? So it's the same length as our numbers array. And then we are calling array.copy, and we are copying from our numbers array to the copy array, and it is numbers.length. So this is the copy right here that's being displayed, and this is the original. And you can see that the copy is actually sorted because we've already called the sort method right here. Okay. Oh yeah, and then, remember that arrays are reference types, so direct assignment copies the reference, not the data itself, right? So here we're copying the reference, and we are not actually copying the data itself. We can also pass arrays to methods, okay? And remember that arrays are passed by reference by default. So if we take a look over here, I've created a method called print array, and you can see that it takes a parameter, or yes, you can see it takes a parameter that is an int array, and we've called it R here, just short for array. And what I've done is I've just looped through each number in the array, and I'm printing it to the console. And then here you can see we are calling the print array right underneath, and we are passing in our numbers array. And you can see what that looks like printed right here. If we go ahead, I added this printing array at the top of the print array method just to show it differently than these first two that we have here. So you can see that we're printing the array, and then we list all the different values in the array. I don't have this inside of my Visual Studio, but there is the null conditional operator. And this is used to prevent null reference exceptions. So for example, we could have a line of code that says int length is equal to numbers and then question mark dot length. And then we could also say question mark 0 at the end of that. And what this does is it gives safe access, it prevents crashes, and it is often used with collections. So the question mark period checks if the variable is null, and it returns null instead of crashing if it is null. So what's happening here is we are checking if the numbers.length is null. If it is null, instead of crashing, it'll just return null. But if it's not null, then it will return the length. Okay. And what the question mark does is it provides a fallback value if the value is null. So if numbers.length was null, instead of returning null, it would actually return 0 in this case because we've given it the fallback value. Okay. So that is how you can use the null conditional operator. And now we can move on to collections. Okay. So collections are really cool. They're very fun to work with. They have dynamic size. So that means that they can grow and shrink. Okay. And they are much more flexible than arrays. Okay. And in order to use them at the top of our code file here, we need to use this line using system.collections.generic. Okay. That's where you can find the collections that we can use. So if I scroll back down here to collections, it's important to note that there is two different types of collections. So we have typed and untyped collections. I would recommend using typed collections. Modern C# uses typed collections a lot more. But typed collections, we have a list of type. We have a sorted list of keys and values. We have a queue of type and a stack of type. So typed collections are type safe and there's no casting required. And untyped, it stores the object, but it requires casting. Okay. And the untyped, right, variations of the typed would be array list instead of list of type, sorted list, and you don't have to include these angle brackets, and then queue and stack, same thing. So how do we work with lists? Okay. So here I have an example. Here we're creating a list of type int. That's what these angle brackets do. They say, hey, what is the type of this list? This is where you provide the type. So we have a list of type int called ages, and it is equal to a new list of type int. Okay. And you can see here, we don't need to specify any length, and that's because it is dynamic. Okay. Dynamically sized. So we can use this add method, and we can add the value 25 to our list, and we can add the value 43 to our list. And we can also use the remove method, so we can remove the value 25 from our list right here. And then we also have a property that we can use with lists called count. And so what we can do is we can write ages.count to the console. And what this is going to do is it is kind of the same as length. And as you can see, it prints 1 to the console. And that may be confusing to you because we did add 2 elements, right? But what we did is we added our 2 elements and we removed 25 right afterwards. So there is only 1 element in our list right now. And it is important to note that remove removes the first occurrence of a specific object, right? So what remove is doing is it's removing the first occurrence of 25. If we were to copy this and paste it again, and then if we were to run this again, if it will run, taking a second, you would see that we actually have a count of 2 now for our list. And that's because there are 2 elements. Oops, I didn't mean to full screen this. 25 and 43 in our list instead of 3 elements. Okay. We also have sorted lists. So sorted lists, and I don't have anything more on Visual Studio here, so I'm going to maximize this. So sorted lists, they're automatically sorted by key, and they are key value pairs. And do note that the keys need to be unique, so they cannot be the same. So what we can do is we can say sorted list, and then we can provide what the key and value are going to be. So the key is going to be an int, and the value will be string. And the name of our sorted list is students. And then we initialize it to a new sorted list of int string. Okay. And then you can use that way. We also have queues and stacks. These behave kind of similar to lists, but they have different functions. So queues are first in, first out, right? The British call lines queues. So that is a great way to think about it. If you're the first in, then you are going to be the first person out. Think about waiting in line at McDonald's or something like that, or at the bank, right? The first in is going to be the first out. Stacks, imagine stacking up bricks, right? So it is last in, first out. So whatever's on top of the stack is going to be the first one out. And it's also the last thing that was put on the stack, right? So that's how you can think about queues and stacks. For queues and stacks, they have a little bit of different language, but they have very similar functionality to the add and remove methods of list. So enqueue is how you add things to the queue. Push is how you add things to the stack. So if we push 10, that is putting 10, the value 10 into the stack. And then we have dequeue. Dequeue obviously is the same as remove, or at least similar to remove, but what it does is it takes the first value out, right? Because it's FIFO, first in, first out. And then pop removes the top object from the stack, right? It's last in, first out. So whatever was last pushed to the stack is going to be popped off of the stack, okay? So just a quick summary, kind of when should you use arrays versus collections. Use arrays if you need a fixed size or there's a fixed size in mind. Use arrays because they can be faster and they work with simple data. Use collections for dynamic size. They're more flexible and they handle complex data a little bit better. So that is the end of this lecture. In this chapter and lecture, we learned about how arrays store data. We learned the differences between array types, and we learned about collections and how they improve flexibility. Okay, so that is all for this lecture, and I will see you guys in the next one.